Let's begin learning how to differentiate some elementary functions. We'll start with the power rule. So we're looking at the derivative of a power law, so d dx of x to the n. We'll work from the definition of the derivative. So this is the limit as h goes to 0 of x plus h raised to the nth power minus x raised to the nth power divided by h. So of course, if we just substitute in h equals 0, we get a 0 divided by 0. So somehow we need to cancel the h out of the denominator. To do that, we'll use the binomial theorem, or the binomial expansion. So we can write x plus h raised to the nth power is the leading term, is x to the nth. Then the next term, which is proportional to h, comes from h. We have n of these in an expansion, so we're just pulling one h, and all the other ones are x's, and there are n of them. So the next term will be n times h times x to the n minus 1, because one of these terms we took an h from. And then the next term will depend on h squared. So all these other terms here I will just represent as dot, 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 meaning that they depend on h squared, h cubed, etc., all the way to h to the nth. So now if we substitute this into our definition of the derivative, we have d dx, x to the n, becomes the limit as h goes to 0. Now we have x to the n plus nh, x to the n minus 1 plus dot, 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 minus x to the nth divided by h. And you see the x to the n cancel the x to the n. So this becomes the limit as h goes to 0 of n h x to the n minus 1 plus dot, dot, dot over h. The h cancels, and then after we cancel the h, then we can take the limit, so that becomes simply n times x to the n minus 1. Okay, so this is a 1. So what have we got? So we got the very important formula that the derivative of the power law, x to the n, equals n. The n drops down, and you get an x to the n minus 1. That is called the power rule. Okay? A very important formula. So in this derivation, I assumed that n was a positive integer, but in fact, the power rule holds for all real exponents n. We can try it for the square root just to show you how it would work. So as an example, we can look at d dx of the square root function. Okay, so that would be x to the 1/2 power. So this is equal to the limit as h goes to 0. We go back to the definition of the derivative. This would be the square root of x plus h minus the square root of x divided by h. Again, we have a 0 over 0, but we can clear that if we multiply the numerator and the denominator by the square root of x plus h plus the square root of h. So let's try that. So we have the limit as h goes to 0. So we have here root x plus h minus root x times root x plus h plus root x divided by h times root x plus h plus root x. And then if we multiply the numerator here, The cross term cancels by design. And then we would have a square root of x plus h times square root of x plus h, which is x plus h. And then the cross term cancels, and we would have minus square root of x times square root of x, which is minus x over h times the denominator, which is root x plus h plus root x. Okay, the x cancels, the h cancels, so that becomes the limit as h goes to 0 of 1 over root x plus h plus root x. And then we can just set h equal to 0 here because we no longer have a 0 over 0. So if we set x equals 0, the denominator becomes square root of x plus square root of x. So that becomes 1 over 2 root x. Okay? We can see that this is also the power rule, because if we write that as d dx of x to the 1/2 power, which is the square root, that becomes 1/2 times x to the negative 1/2 power, which is the exponent reduced by 1. So the power rule also works for the square root function. And later I'll show you that it works for all real values of the exponent. So let me summarize. Here we've derived the power rule for positive integer exponents using the binomial expansion. I also show you that it holds for the square root function. So the power rule to be remembered is that the derivative of x to the nth is equal to n times x to the n minus 1. I'm Jeff Chasnoff. Thanks for watching, and I'll see you in the next video.